Hey everyone, welcome back. I'm Praveen with more than 20 years of experience in software engineering and currently working as a staff engineer in a global financial company and previously was a technical lead at Microsoft. Based on my last videos, I hope you are enjoying playing with Cursor, the AI code editor combined with Claude 3.5 Sonnet. You can use Cursor with other large language models and especially with OpenAI GPT-4o as well as Mini, but personally I found Claude 3.5 to be faster and more advanced as my AI Copilot. Last few videos, I basically showed how to build web apps using Cursor with Claude from scratch. I know, they are very simple like toy apps only using HTML, CSS and JavaScript. One of the common feedback I'm hearing is that most of the use case we are seeing on the internet using AI Copilot is for very primitive apps that most of us would not be working on in enterprise software. I think that is a very valid statement and natural if we look at the historical progress of such disruptive technologies. I often compare using AI as a pair programmer to that of using a tractor in agriculture. It took 20 to 30 years to significantly transform and disrupt the agricultural industry in the United States. OpenAI released ChatGPT 3.5 only at the end of 2022, and if we look at the progress of AI and large language models, I think it is growing substantially. So my understanding is AI and large language models are not going to replace software engineers, but the way we build software is going to change significantly. Having said that, in this video, I have switched gears and experimenting with how an experienced engineer can leverage AI Copilot, such as Cursor, to understand an existing large code base and fully leverage it to start delivering features in a short amount of time. In order to show the workflow that I have found effective, I have taken Kubernetes as an example of a large and complex code base as it is open source and we can play with it. When a senior engineer joins a new project or team, they usually start with reading documentation, starting with a high-level introduction including major features, components, high-level design and product roadmap. Then the expectation is usually to set up the whole or part of the project locally and be able to run the unit test. I think so far the engineer is navigating breadth-wise to get as much information about the project at high levels as possible. After navigating breadth-wise and having that feeling to conceptualize the project at high level, they would start digging depth-wise. Normally for an individual contributor, it is natural to focus on one specific feature or non-functional requirements of the project, and this is where I think AI Copilot can be very helpful. Now let's jump into the demo and I will show you how AI Copilot can play the role of a peer senior engineer, first to help you understand the technical details of the project, and then we'll deep dive into one of the feature requests and implement using Cursor. For the high-level architecture, I usually prefer to understand why the product exists without even going into too much detail. So I use the following prompt and web as a context for Cursor to use. You can see on my screen, I'm showing you the Kubernetes code base that's available on github.com, and you can do the same thing. So you can go to Kubernetes repo on github.com, and then what I've done is I have cloned this repo. So you can go here and then you can copy this and you can clone it to your local folder. So after I have done the same thing here, I have cloned on my folder here, and what I've done before is I have run the indexing. So the way that, as you know, the way the Cursor works is it will index all the code base here, so that when you chat with it with context and with code base, it knows all the relationship between different code. So I've already went ahead and I have indexed that. So this you can also see here under the settings of the Cursor settings here, and if you go under the features here, you can see that here the code base indexing. So this is currently showing the indexing, and it is now showing 100%, which means that the Kubernetes code base is 100% indexed, which is important because when you send the command to the Cursor, it will answer it based on this indexing. So make sure that before you use any large code base, it is able to index it fully. And sometimes depends on the type of processor that you are using, it might take a little longer, but it's always a good idea to let it index it complete and then start playing with the chart. So having said that, now the first thing that I'm going to do is I will open up a terminal by doing Command L in Mac and Control L if you are on Windows. So here, as you can see here, by default, the web is already selected, which means that I will be using the web context for my first prompt. So I'll just paste this here and I will send it to use this chat without the context. So what it does is it goes and it will look into the public information, because as a first breadth-wise understanding of the project, I want to understand what this project is. So so as you can see here at the high level, it will give you like what Kubernetes provides, several key features and benefits such as container orchestration, scalability, self-healing, service discovery and load balancing, storage discovery and load balancing, storage orchestration, automated rollouts and rollbacks, secret and configuration, batch execution, extensibility. So as you can see here, now you can read it what it does at the high level. It's automate the deployment, scaling, and management of containerized applications. And I totally understand that if you are new to the software, or even if you have only worked for a few years in only smaller applications, this may be a little intimidating for you to understand. So I encourage that you learn about the Kubernetes before you continue watch the video, so that you have at least a high-level understanding of what Kubernetes does and what its high-level objectives are from the product standpoint. And then there are more here. The good thing is it also gives you the web pages here. I think what the OpenAI lack is it does not give you the reference. At least the last model that I used did not have this, but here it has reference to Wikipedia's article as such, so that you can go into further and learn about it. When jumping into a new code base, understanding the core components is crucial. Let's ask Copilot to give us a summary of Kubernetes structure based on the code base as context. Cursor open as previously, and now what I'm going to do is I'm going to paste the prompt that I would be using to find out the major components in the Kubernetes code base. So I will open up again the chat window, and here the context is not yet selected. So I'm going to go ahead and I'm going to add as a code base, or what I can also do is I will paste this prompt here, which is basically summarize the core components and architecture of this Kubernetes code base, and then I'm going to refer to the code base here, so that instead of now using the web context previously as we saw, now we would be using the code base, which is actually local right now. So let's see how it gives us the core components and architecture based on the code base. So it will take some time, again, based on the system you are using, and as it is fetching it in the background, so it's saying about the deployment, how it does the deployment, about the service, the config map, the secret, the ingress, persistent volume and persistent volume claim, architecture overview, best practices for scalable, configurable, and maintainable web applications. Okay, so what I'm going to do is I'm slightly changing my context here because I'm not getting a very good answer. So I'm going to use the code base, but I will do the core components of this Kubernetes code base. So let me just do this one now, and I will not use the web as a context because I want Cursor to go into the Kubernetes code base and tell me the answer, and I will use this one. Okay. As you can see here, it's now again going through those. Yeah, for some reason, it's still giving me the same answer. So what we can try quickly here is now instead of using the plot model, for which it seems to be not very good. So let's try it out, the GPT-4o, and then we will use the same prompt. I'll remove the architecture, and then I will use the same code base. Okay, so let's see here how the GPT-4o will be different. It looks similar: deployment, service, config map, secret, ingress, persistent volume, and persistent volume claim. All right, I think it is not perfect. Like I would like more than this, but I think this is still good if you are working in a big code base, and then now you can go at individual to understand these. Once you understand the big picture, the next step is to find the most important functions. For example, let's locate where Kubernetes handles pod scheduling. And I've already pasted the prompt here. As you can see here, I put the prompt, show me where pod scheduling is handled in this code base, and by giving the context as a code base and then pressing this code base. So now it gives me the answer. So to find where pod scheduling is handled in the given code base, I'll need to examine the relevant files. And based on the provided context, the most likely place for pod scheduling would be in the Kubernetes related file. Let's take a look at the scheduler.go. So now what we can do is we can also click on here, but before that, it also gives you the high level of how this file works. So as you can see here, it says start line 1, 185 line of code it has. So before going into that, I find this very helpful. So after examining this file, we can see that it contains the code scheduling logic for pods. So the way, if you don't know what this is how the pod are assigned to the node, and it is explaining that process here. So the scheduler struct, which was the configuration, this is more like the data structure, the schedule method or the scheduler struct. Okay, so it's giving the method and then other method detail. So the actual node selection algorithm is implemented in the find nodes that fit method. So here, I thought you would be able to click here and go, but it looks like that's not the case. So now we can actually jump into that code here, and then we would be able to see the implementation. This is the first part of the series on how to leverage AI Copilot to work on complex projects and large code base. As we saw, it's a powerful tool that saves time and boosts productivity. If you found this helpful, be sure to like the video and subscribe to my channel. See you next time. Bye.